right, here we go. So let's share the screen. Where am I at? Woo. All right, number one is this right here, 1 over x. All right, so for a lot of these graphs here, and again, sorry, I can't grip the Apple Pencil well, so it's really, I guess kind of messy in here, and I apologize. Well, here we go. Here's an x and here's a y. Okay, and remember that the asymptotes for the 1 over x function are the x-axis and the y-axis. Okay, are we good with that so far? And you don't need to be so accurate with these graphs here. All I want from you guys is the general shape. Okay, for at least these first two problems. I just want the general shape. All right, so, and also I suggest that you guys bring colored pencils probably on this during this test, because you're going to have to decipher, you have to show like the different equations. So for this one here, what I would like is, all you have to do is just do this right here, this and this. Okay, so this is, and label it, y is equal to 1 over x. This is the parent, y equals 1 over x. Okay. Now, letter B is what? This right here, the +3. What does the +3 do? It shifts it left 3 times. So all you have to do is just go, I don't know, just go 1, 2, 3, just estimate. We'll just do this and do this. And make sure your vertical asymptote is shifted 3 times. That makes sense? Okay, all right. What about the +5? The blue graph does what? It goes up what? 5 times, right? So we're just gonna do, this. And this. The vertical asymptote stays the same, but the horizontal asymptote goes up by 5. Okay, try to label as much as you can. Like this is y is equal to 1 over x plus 3 plus 5. This is y is equal to 1 over x plus 3. Okay, asymptote is y is equal to 5. Okay, things like that. Just try to label as many graphs as possible. All right, and then go from there. So like this side right here should be y is equal to 1 over x plus 3 plus 5, so on and so forth. Okay, this blue one is 1 over x plus 3. Okay, so that's the first 3 right there. Any questions on that? Cool. Number 4. All right, so now the fourth one. We have a -1 right here. We have a -1 over x plus 3, right? What does a negative do? It reflects over what? The x-axis. Good job. So let's graph this here. All right, so what happens here is, let's draw the parent again. So the parent is right here. That's the parent. Reflected over the x-axis would be right here and right here. Okay, sorry, I should reflect over y. Huh? When does it reflect over y? When does it reflect over y? When the negative's on the denominator. JP's on fire right now, yes. All right, are we good? I kind of notice actually that whether you reflect over the y-axis or the x-axis, in this situation, when you're graphing the parent, it looks the same, right? Okay, right? It looks the same in this situation, right? So let me graph this a little bit better. Okay, so it looks the same. All right, now if it says but how do we graph this? What do we have to do with the black graph right there? Yeah. What did I just graph? I just got the negative, right? This green one reflected over the x-axis, right? This green graph reflected over the x-axis. That's why the black inked one is reflected. That's a negative. Now, what do I do with the +3? Shift it to the what? To the at the right, left 3 times. Okay, so I am shifting this. So I'm going to bring the asymptote 1, 2, 3. So I'm going to shift it right 3 times. Sorry, left. Sorry, I'm shifting it left 3 times. By the way. Thank you. All right. We good? All right. Any questions? There's a part of me that doesn't want Jeffrey to understand this, you know.
Yeah.
I'm like, yes, you know, kind of thing. I'm like, yeah, no question. All right, what's up? Yeah. Yes. So the black graph is -1 over x. And then the blue one is the x plus 3, the 1 over x plus 3. Okay. And again, for this section, you do not need to like plug in a number and then you can if you want to, but it's going to take too much time. I just want you to understand the transformation. That's it. Okay. Yes.
For the third problem, for the first problem,
Third part.
the horizontal asymptote, would it be at 0 or would it be at 5?
For the third problem, it would be at 5. Because it would shift up 5.
When you like go by like the rule, like since m is greater than n, it said that the horizontal asymptote should be y equals 0. Why does it like send that rule?
Wait, say it right here?
Yeah.
Wait, sorry, can you say that again?
Like when you go by the rule of like the n is greater than n, the y equals 0, why does it change?
Because you shifted up. So we're talking about just a parent function, right? But because you should recognize that there's a +5 right here, and because the whole graph is shifted up by.
Because they're going to shift after.
Yes, yes. Good question. Yes, Kayla.
So what's the difference between
No problem.
1 and 2?
So now let's do that one right now. So what is the difference between the -1 and -2 here now? Let's do that one. The -2 is what? How do we describe this transformation? It's a vertical stretch, right? And remember what we did, look at this. That's the reason why I showed this slide right here. Okay, what does a vertical stretch look like? You see this blue part right here? That's the parent. So the vertical stretch does this, right? It goes inside right here, right? So apply it the same way, but with this graph here. So now, where's the graph that we did here? This is the graph that we did. So now what will it do here? This is the blue is what we just graphed right here, right? This is the y is equal to -2. This is -1 over x plus 3, right? So now what will it look like? I'm going to use it in green, or not green. Let's go yellow or black. Yeah, okay, red, actually, red. All right. If I do y is equal to -2 over x plus 3, that means it's going to look something like this right here. Okay. Again, I would bring colored pencils for this. All right. Cool. I'm recording a video for just Kira. All right. She's probably gonna be the only one who watches it. So, good luck today, Kira. Good luck. Break a leg.
No, it's 150. It's not really possible. Yes, it is.
Don't worry about it. Soccer is not important. It's okay. It isn't. I told you it isn't. I don't want it to be important. All right.
Yeah.
All right, here we go. So, are we good? All right. All right, number 2. All right, so number two, kind of the same thing here, but let's try this here. All right. I want to talk about domain and range in a little bit. All right, here we go. So this is the 1 over x squared graph. Okay, you guys see that? All right, so this is the y equals 1 over x squared. All right, what's the 1 over x minus 2 squared going to do? It's going to move it over 2 times to the right. So we go here, vertical asymptote is here, and it's going to be moved 2 times to the right. Okay, oh, that's so confusing. That looks awful. Let's do it with blue. Okay. Cool. What does the plus 5 do? It moves it up 5 times. So this graph right here is going to go up 5 times. You guys see this? And the asymptote is going to be y is equal to 5. What does the negative 1 do? Let's graph the original. This is the original back again. This is the y equals 1 over x squared. What does the negative 1 do?
Reflect over the x-axis.
Reflects over the x-axis, so it's going to do this. So this is y is equal to negative 1 over x squared. Are we good? What does the what is the negative 2 do then? If I had this, what will it do? It will what? Vertical stretch, right? So I'm going to use the yellow. Let's do something like this. And then if I had, that's this right here. Then if I had y is equal to negative 2 and then x, what was it, minus 3? X minus 2. Minus 2 squared, right? This yellow graph will move to the right. And then if I did the plus 3, it would go up 3. Okay. Are we good?
Yeah, like where do you find the transformation? As far as like, you know, like what the rules are.
So remember as y is equal to a over, and I guess I could put the a out here. Or yeah, it could be a and then 1 over x minus h squared plus k, I guess. We could do it this way. All right, that's probably the way to go. All right.
That's just really probably like, you know, the negative in some ways,
Yeah, so the negative reflects over the x-axis.
yeah, but those rules.
So y is equal to a and then the negative x minus h.
Where do you find them?
I'm telling you right now. I could give you a resource, whatever, but I think I did, but yeah. Yeah, you know what? What I want to let's look on a Desmos. It looks a lot cleaner. All right, so let's do that. Okay. Okay. Let's look at it right here. So here we go. All right, 1 over x squared looks like this, right? You guys good?
Yeah.
There we go with that. Now Joey's on his phone.
I took a picture of it.
Okay. All right, we good? We good? There you go off your phone. Just listen to me. All right, we're good. Now, 1 over what? And then x minus 3 squared does what? Or it's 2. Sorry, it's 2. My bad. 2. It's just what? Shifts to the right 2 times. We good? All right. Then if I put a what? A plus 5, what does it do? Moves it up 5. Okay. Yeah. Right 2, up 5. We good? Okay, then what? If I put a negative on the top, let's go with negative, I want to put the negative on the parent, -1/x². What does that do? It reflects over the x-axis, right? We good? All right. Okay, and then what do we do with this? -2. And then what? X minus 2. X minus 2, what does that do? It reflects over the x and it shifts it over 2 times, right? And then it moves this up 3 times, yeah. Wait a second.
You're just shifting it.
Yeah, so the asymptotes are getting shifted as well, right? And so, yeah, that's that. Yeah, Tony, what's up? The horizontal stretch? So the horizontal stretch, that's a good question, actually. That's a really good question. So you see what, let's see here. Let's go back. Let's go back to this right here. See what the horizontal stretch does? So the purple is the parent. The horizontal stretch goes like inside like this, and it kind of goes along. So as long as you draw it inside like this, you're good. Okay. So this is the vertical, this is a vertical stretch by 2. All right. Cool. All right. Here we go. So look at these graphs too. Like these are these graphs on your slides. These will help you out a little bit too. Okay. All right, good. So good question. So the domain is all the possible. Let's go with this problem right here. Domain would be what? Let me see. Let me share this one second. Domain are all the possible x values. All right. So what are all the possible x values? All right. So you see, I have an x value all the way. I have an x value, x value, x value, right? But where do I not have an x value? At 0. So the domain is all real numbers except 0. Okay, that's all it is. All right, all real numbers except 0. Right, because as soon as I hit 0.1, I'm gonna have a value here, right? All real numbers except 0. You could also write an interval notation. When you write interval notation, it's just this. It's -∞, 0, 0, infinity. What is the range on this one? On this graph, all the possible y values. Oh my God. Good job. Okay, so 0 to infinity. This is just for this one, particular one. But what happens though, if I put, let's say a +5 right here? What happens there? What would the domain be, and would the domain stay the same? Yes, it does. The domain stays the same. But what about the range? Range changes from what?
5.
Good question. So you only have to do domain and range for that last problem. Oh, okay. All right. It's not gonna be for every single one. We should do the last problem. Just the last problem.
On both of them.
Yeah. That last problem. Hear you. Yeah, it is. I can change that. Yeah, we're good. Yeah.
The domain for
The last one. So let's look at the graph here. So it would be -2, and then it would be x minus 2. All right, so what would the domain and what would the range be? So the domain is all real numbers except what for this one?
2.
2, good job, because the asymptote's at 2. All right, so that's good on the domain. What about the range? So this one's a little different. It'd be what? Remember, it went up 5. So what would the range be? It didn't go past 5, right? So 5 to negative, or negative infinity to 5. You want to do the lesser first? So the negative infinity comma 5. And they're both in parentheses because, remember, it's an asymptote, and asymptote, it doesn't hit the asymptote, right? It's like, it's on that verse, right? Yeah.
Remember, like a normal, like, function, not like the squared one, it's that for the range, maybe the following, nothing like that, right?
Yeah, that's fine. You'll use the domain, the interval notation for the piecewise when we do that.
It's +3, not +5.
Oh, plus 1 gets +3. So then it would be what? What would be different? What would be different about, this whole conversation is gonna be on YouTube, you guys. Your conversation. So I hope, yeah, I'm recording it right now, so, yeah. So it would be a 3 on 5. I like it when they get excited, you know that they get it. So good job. Good job.
Yes.
Yeah.
I'm saying like all your members should have like X is not.
Yeah, you do whatever you want. As long as you express to me, express to me the right answer, you're good. You do it in equality. Okay, we don't have to do it in inequality, right? Like this is X is less than 5. You're not doing it. All the same thing, right? Cool. All right. We're good with that. Was 1 and 2?
Mr. Chairman, just making sure, we have to graph every single one of those.
Yes, but again, remember, you're just doing the general formation. You're not exactly pinpointing each point, right? You're just giving me the general shape of each graph. All right. Yes, JP, what's up?
Like, is there gonna be a question where we have to do everything like specifically?
No, not for this first part, no. Okay, everything is just gonna be on transformation based. All right. Number 3, state the equation, using the following description. So it's a rational squared function. So when I say rational squared function, it means that the would be 1 over x squared. Shift right 4. So that would be 1 over x minus 4 squared. Up 3, you would just put +3 at the end. Reflected over the y-axis. So what would happen? It would be 1 over the negative, and then x minus 4 squared +3. Horizontal stretch by 3, you would put 1/3 inside the parentheses here. Okay. So I'm hoping that you guys are making connections between, that last transformations portion, okay? Like that last transformation part, the section that we did. What would be the, if I did the vertical stretch by 3, let's just say that, it would be 3 over, and then x minus 4 squared plus 2, whatever. So the vertical stretch of 3 would be on top.
So you make it a fraction.
Yes. All right, number 4, just, yeah. Oh, go ahead. Sorry. This is the answer right here.
Like, Gord, you can see how slow the.
Yeah, it's a little bit lagging a little bit, yeah. Are you good? Number 4, describe the transformation of the following equation. All right, just you go step by step, reflect over x-axis. Right, because the negatives on top or negatives on the side of the fraction. Left by 2, up by 3. And what else? Vertical stretch by 2. I think that's it, right?
Do we need to state what type of function it is or no?
Yeah, I mean, I maybe put 1 over x squared is the parent. Vertical shrink would have a fraction on the numerator.
Oh.
All right. Are you good?
Would the shrink have a normal number under the denominator?
Normal number, it would be, yeah, it would be like a whole number in the denominator, yes. Are you good? All right, number 5. All right, 2.9, greatest common integer or function, it would be 2, right? Well, what about 3.4? 3, what about 6.4, negative 6.4?
7.
Negative 7, good job, be careful with that one. What about the last one?
Positive
So-
5.
So it would be negative 6 here, right? This is negative 6, right? But what about this negative? So it would be good positive, so it would be positive 6. Okay, so be careful with that one. That one's probably the one that people get wrong. Are we good? All right. Okay, step functions, parents, always graph the parent first. The parent is right here. Graph it in red. The closed circle will be on the left. The open circle will be on the right. This is 1. This is 2. This is 3. I'll provide graph paper for you. All right, so here to here is a parent. You guys remember these? Okay. All right, so -4 would do what? It would move it to the right 4 times, right? So 1, 2, 3, 4. So it would be right. It would be right here. Okay. Down 3 would be what? You move each one 3 times, right? Down 1, 2, 3. Once you can do 1, it's pretty straightforward. All right. So far, so good. All right, what does the 2 now do? All right, the 2, what it does is, if I'm gonna graph this, and I have the step function like this, pretty much. We graph 4 steps for each one. What the 2 does is, it just pretty much, here's the original, and then it kind of skips a step. So it's like these are steeper steps here. It's not exponential, but it does just, yeah. It can't, it was, in some sense it does, yeah, I get it, because it does kind of form a parabola a little bit.
Yeah.
So, but let's not think about that right now. Yeah. That is a good observation, though. Are we good? All right. Last but not least, number 7. All right. So parking at an airport. All right. So I think a lot of you guys got this down. It's just a matter of. So make sure you're not using an equation for this, but let's start doing the step first. All right. So from 0 to 1, right? It is right here, right? Or sorry, I should undo that. At $3, right? It costs $3 from 0 to 1, right? Right when it hits the 1 hour mark, what? You're gonna get charged another $5, right? So this is gonna be 8. And then 3 would be what? At 13, right? And then at 4, what? 18, good job. 5 would be what? This is 18, 23, 28, right? Wait, hold on here. I messed up. And then what happens on the 6th hour? Does it go to 34? Something said 33? No, it stops at 30. Why does it stop at 30? Because that's the max right there. Okay, so this would be the graph that you would have to graph. Now Jeffrey actually brought up a good point here. Why wouldn't you do an equation? Why wouldn't, like, I think Jeffrey, you said what, y equals. It was, y equals 5x plus 3. That's a good observation, I think. Y equals 5x plus 3. I graph this, right? This would be 1, 2, 3. And go up 5, right 1, up 5, right 1, right? Now, why wouldn't this work in this situation? Yeah,
This is the maximum.
there's a maximum, that's good, so it caps off somewhere at $30 in here, right? But what happens in between? Like, see how you have 1 hour in here, right? Let's say you park 1.5 hours. How much would you be charged? Good. Okay, so in this, but if you had the equation, it would be somewhere along this line, and that's simply not true, right? It would be somewhere in between like $3 and $8, or $8 and $13, right? So that's why the line doesn't work here. And that's why the step function is key here, because anywhere between 0 and 1 hour, you are paying the $3. Anywhere between 1 and 2, you are paying the $8 here. Okay, that makes sense? All right. And so now, last thing is, what if I put the equations in a piecewise, in the piecewise form? This would be the f of x. You could put the g of x. You could put whatever. All right, and let's put it in this bracket here. It would be 3 between what? 0 and 1, correct? Hello? Sounds good. Right. Lucy, you're going home, right? Then it would be what? How much would it be? So after the first second hour, it would be what? $8, right? And it would be at the 1 hour mark till when? 2. You guys getting this? All right. Then it would be 13 between right at the 2 hour mark to the 3rd hour. And then it would be 18 between the 3rd hour and the 4th hour. 23 between the 4th hour, 5th hour. 28 between the 5th hour and 6th hour. Right? Then what happens? Bye. And then what happens? And then it would be 30. Give me the interval notation. 6 to infinity. Good job. Or you could say 6 to 24 because it's a 24-hour period, right? It's every day that you get charged 30. But if you put infinity, I'm not going to mark you down on that. Say again? So, because if you don't park, okay, so like that's a good question, and it's kind of like one of those I've kind of escaped a little bit. Like if you don't park there, right? Like if it includes 0, right? You're not parking there, so it would probably start counting at the first minute, right? That you park in there. If you include 0, then might as well not park there, right? You're not parking, so that's why I didn't include 0 on that one. But if in all honesty though, if you put a bracket there, I would have marked you wrong, kind of thing. It's a technicality. It's not a, yeah. Okay. Cool. You can't have a closed bracket with the infinity. You can't, because infinity is like it's a concept, not a specific number. It's a concept. So yeah. Then you could put a. Yeah, if you put, then there'd definitely be a bracket there. Yeah. Cool. All right. Let's take a 5-minute break. All right. Good job. Let's take a 5-minute break. I'm gonna upload this.